Hello viewers, in today's class we are going to solve one important definite integral, and in order to evaluate this definite integral we'll make use of the properties of definite integrals, right? So let us start. So here we have to integrate this function x over 1 plus cos square x from 0 to pi, right? So let us call this integral as I. Now in the initial stage we have to make use of the property which says that if we have to integrate f of x from 0 to a, then this can be written as 0 to a f of a minus x dx, right? So here we have pi for a, and we'll make use of this property to this integral, right? So now this integral I can be written as 0 to pi, and x would be replaced by pi minus x. So here we have pi minus x, and here we have 1 plus cos square pi minus x, right? So what we have done here, we have used this property, and we have 0 to a, here we have 0 to pi. For a we have pi, and for fx we have x over 1 plus cos square x. In the next step we have replaced x by a minus x, right? So here we have replaced x by pi minus x, right? So we can take this integral as integral number 1. Now here we can write this integral as 0 to pi pi dx divided by here we have pi minus x, and here we have 1 plus cos square pi minus x is simply cos square x, right? Because we know that cos of pi minus x is equal to minus cos x, and cos square pi minus x is equal to minus cos x whole square. So here we have square of negative is positive, so here we have cos square x, right? Okay, now we can split this integral into two integrals. So we have 0 to pi, then we have pi dx over 1 plus cos square x, and then we have minus 0 to pi x dx over 1 plus cos square x, right? Now this integral is our original integral, that is I. So we have 0 to pi dx over 1 plus cos square x, and here we have minus I, right? So this integral is replaced by I. Now taking I to this side, so we have I plus I, and taking pi outside the integral sign, we have 0 to pi dx over 1 plus cos square x, right? And I plus I is equal to 2i, so I can be written as pi over 2, and integral from 0 to pi dx over 1 plus cos square x, right? Now we have to integrate this integral. So in order to integrate this function, what we have to do, we have to divide the numerator and denominator by cos square x, right? So we can now write I is equal to pi over 2. Here we have 0 to pi, and we have 1 over cos square x dx divided by 1 plus cos square x divided by cos square x, right? So we have divided here the numerator and denominator by cos square x, right? Okay, so now we can write it as pi over 2. This is 0 to pi 1 over cos square x is sec square x dx. So this is secant square x, and here 1 plus cos square x over cos square x can be written as 1 over cos square x plus 1, and 1 over cos square x is secant square x plus 1, right? So here we have secant square x plus 1. Now secant square x can be written as 1 plus tan square x, because this is the identity. 1 plus tangent square x is equal to secant square x. So this secant square x is replaced by 1 plus tan square x. So therefore I is equal to pi over 2, 0 to pi secant square x dx, and secant square x is 1 plus tan square x. So this one and this one would become 2. So we have 2 plus tan square x, right? Okay. So now viewers, at this step, before proceeding further, we have to make use of one more property which says that if we have the integral from 0 to 2a f of x dx, then this integral is equal to 2 times of the integral from 0 to a f of x dx, right? But provided there should be one condition, and that condition is f of 2a minus x should be equal to f of x, right? So in order to evaluate this integral, we have to now make use of this property, right? Okay, so here we have the limits from 0 to 2a, right? So here this pi, this upper limit can be written as c. We can write this integral as pi by 2 from 0 to 2 times pi over 2, right? So we can write this pi as 2 pi over 2, because 2 and 2 get cancelled, and here we have the integrand secant square x over 2 plus tan square x dx, right? Okay, so now here this is the value of a, because we have 0 to 2a, right? So we have a is equal to pi by 2. So now as per this property, we can now write this integral I as pi over 2 times 2 times 0 to a, and for a we have pi over 2, and we have secant square x over 2 plus tan square x dx, right? So we have used this property. Now we have to see whether this condition is satisfied or not. So here we have f of 2a minus x equal to f of x, and for f of x we have this function secant square x over 2 plus tan square x, right? So f of 2a minus x, so for a we have pi by 2, so 2 times pi by 2 minus x is equal to f of pi minus x, right? So f of pi minus x is now equal to secant square pi minus x, and here we have 2 plus tan square pi minus x, right? So now we know that sec of pi minus x is equal to minus secant x, and tan of pi minus x is equal to minus tangent of x, and their square is obviously positive, right? So this expression now becomes equal to secant square x over 2 plus tan square x, right? Because if we make square of both sides, then this square of negative becomes positive. So we have secant square x over 2 plus tan square x, and this is nothing but f of x, right? So we see that f of 2a minus x is equal to f of x. So now this 2 and this 2 get cancelled. So we have pi 0 to pi by 2 sec square x over 2 plus tan square x dx, right? Now we'll make use of the method of substitution. So we'll put t is equal to tan x. So dt is equal to secant square x dx, right? So for secant square x dx we can write dt, and for tan x we can write t. Now we can change the limits. So when x is equal to 0, then t is tan of 0, that is 0, right? And when x is equal to pi by 2, t is equal to tan pi by 2, which is not defined, which is equal to infinity, right? So now this integral becomes I is equal to pi, and the limits are from 0 to infinity, and we have here dt and 2 plus t square, right? So now this integral I can be written as pi 0 to infinity. This is dt over square root of 2 square of root 2 plus t square, right? Now this integral is similar to dx over x square plus a square, and which is 1 over a tan inverse x over a, right? So here this capital A is equal to square root of 2. So I is equal to pi, and we have 1 over square root of 2 tan inverse t over square root of 2, and the limits are from 0 to infinity, right? Now I is equal to pi over root 2, and we have tan inverse t over square root of 2, and the limits are from 0 to infinity. Now we can simply substitute the limits and we'll take the difference. So we have pi over root 2, and when we substitute infinity over here, then we see that we get tan inverse infinity minus tan inverse 0, right? And we know that tan of pi over 2, that is tan 90 degree, is equal to infinity. So tan inverse infinity is equal to pi over 2, and tan 0 is equal to 0. So we have tan 0 equal to tan inverse 0 is equal to 0. Here tan inverse infinity is equal to pi over 2. So I is pi over root 2, and here we have pi over 2 minus 0, and this is pi square over 2 root 2, right? So therefore the value of this integral is equal to pi square over 2 times square root of